All right. Hopefully you're enjoying all of this extra daylight outside. Okay. Um, we are starting with 6.4, simplifying complex fractions. Okay, so what we're going to be doing here is looking at how to simplify something that looks like this. Okay, and we'll take a look at two different methods. So you might have something like this here, this expression here, and then you also have this one down here. Okay, and so this here is called the complex fractions when you see fractions within a bigger fraction. Okay, so let's take a look at method one, where we use division, which is what you guys are familiar with. So let's just kind of, you don't have to copy this down, but if you have something like this, right, 18 over 6, right, that's a fraction, but this is also another way to represent division, right? So this here is equal to 3 if we reduce it, right? And 18 divided by 6 is also equal to 3. So fractions are also another way of representing division, okay? So with that in mind, this is like saying 2 over x plus 5 divided by x plus 3, okay? So that's going to be our first method, method 1, where we look at this as a division problem. Okay, so let me go ahead and copy that down over here. 2 over x plus 5 over x plus 3. So if we take this and we rewrite it as a division problem, then this looks like 2 over x plus 5 divided by x plus 3. Okay, so now this becomes an addition problem in here. Okay, so I can go ahead and put that 5 over 1. My LCD is x. So this is going to be 2 over x plus, and I have to multiply that by x over x. So I get 5x over x. Now they have the same denominator, right? We covered adding and subtracting rational expressions in the last the last section. Okay. All right, so that's all I did here. If you're like, what did you just do? Okay, so I got the LCD, which is x, and I made my denominators look like the LCD. This one already looks like the LCD. This one I need to multiply by x over x. Okay. All right, and now I can go ahead and add these because they have like denominators. So I get 2 plus 5x all over x divided by x plus 3. Okay, so now I do this division problem, and we looked at that a couple of sections ago, and I keep the first fraction. So I'm going to keep this one. I'm going to flip the other one. This is like over 1, so when I flip it, it's going to be 1 over x plus 3, and this is going to be multiplication. Okay, and then when I multiply this out and nothing cancels, so I get 2 plus 5x in the numerator, and I get x times x plus 3 in the denominator. If I multiply that all the way out, I get that in the numerator, and I get x squared plus 3x in the denominator. Okay? Okay, so that is the division method, right? So dealing with this by turning it into a division problem, which then becomes usually some sort of addition or subtraction problem, and then a division problem. Okay, so here's method number 2. Normally, I teach method number 2 only, but some students really love method 1 using division. I love method 2. Okay, so multiply by LCD. So to clear fractions. Okay, so let's have a look. Same problem. So 2 over x plus 5 all over x plus 3. Okay, so here what I do is I look at each term here, and I have 1, 2, 3, 4. I have 4 terms. I only have one that's a fraction, so very easy to find the LCD between the 4 terms, because this is like over 1, over 1, and over 1. So the LCD would just be this x here. Okay, so my LCD is x, and what I do is multiply all the terms by your LCD. And by doing this, you end up canceling that fraction, that one little fraction there. Okay, so I'm going to go ahead and multiply everything by the LCD. And by doing that, these guys cancel. And I get 2 plus 5x over x squared plus 3x. And there's the answer. Okay, so you can see how there appears to be less work in this method. And who doesn't like less work, right? Okay. All right, so let's try that again. Let's look at this example. Okay, let's simplify. 2 over x plus 3 over y over 3 over x minus 4 over y. Okay? All right, now, if you use, here, I'll do the 2 methods here. If you use the division method, then that would turn into 2 over x plus 3 over y divided by 3 over x minus 4 over y. If you use multiplying by the LCD to clear fractions, clear fractions method, then here the LCD between all 4 terms, 1, 2, 3, 4, we see an x and we see a y. LCD is xy. Okay? And I would have to multiply all 4 terms by xy. Okay? All right. So let's go ahead and do both methods. That way you can decide which one you like. All right, so if we do the division method here, my LCD is xy, so I need to multiply 2 over x with y. And I need to multiply 3 over y with x. Okay. And then here, also the LCD here is xy, so I need to multiply 3 over x with y over y. And I need to multiply 4 over y by x over x. Okay? And then here I get 2y plus 3x over xy divided by 3y minus 4x over xy. And then I turn this into multiplication by the reciprocal. So change that to multiplication. Take the reciprocal. And then here, the x cancels, the y cancels. I'm left with 2y plus 3x over 3y minus 4x. Okay? All right, so that's the division method. LCD method. I would take this problem, 3 over x minus 4 over y, and I would multiply everything by the LCD, which we said is xy. So multiply here by xy, here, here, and here. And by doing that, your denominators cancel out. X cancels, y cancels, x cancels, y cancels. Okay? And what's left is, right here, we get 2y. Over here, I get plus 3x. Over here, I get 3y. And over here, I get minus 4x. And that is the exact same answer that we have down here. Okay? Yeah, so you can see why I like this method a little bit more than this method over here. But like I said, when I teach this section, when I put this type of problem on the test, I was always getting one of two results. Completely wrong, or they use this method. And so I thought, okay, when I wasn't even teaching this method. So I thought, okay, well, maybe nobody really understands this method. So I started to introduce this method. Okay. So you can use division if that just sort of makes more sense to you, especially since we're coming off of addition, subtraction, multiplication, and division of rationals. So this sort of ties it all in together. But same this here, maybe students think it's just one extra method that they have to learn. Okay, but that's going to be the method that I use. Okay, so let's take a look at another example. And I'm going to be using method 2 where I clear the fractions. Okay, so let's go ahead and simplify. Let's suppose that I have this, a squared minus 3a plus 2 all over 3 over a minus 2 over a minus 1. Okay, so we definitely have to factor that. Okay, so let's see. Let me do it next to it so I don't have to write everything all over again just so I can factor this. So this is going to be a times a minus minus 2 and 1. Okay. All right. So clearing the fractions, I take a look at all of them. So this one here, a minus 2, a minus 1, a minus 2, a minus 1. So I see here that the LCD is going to be a minus 2 and the a minus 1. So if I multiply everything by this, all of the denominators will cancel. Okay, so let's take a look. So I have 1 over a minus 2, a minus 1, 3 over a minus 2, 2 over a minus 1. Okay, so if I go ahead and multiply by the LCD, a minus 2, a minus 1, so I have to multiply everything there. And remember, you're doing this to clear your fractions. So if you end up with fractions still, other than this main one right here, okay, if you still have a fraction there, there, or there, then you miss the point. Okay, so when I multiply everything by the LCD, we see here that the fractions get cleared. That one gets cleared, that one gets cleared, and that one's cleared. Okay? And so the final answer in the numerator here, everything cancels, so I'm left with 1. And down below, I get 3. I'm going to go ahead and distribute this. 3 times a, 3 times -1. Okay, and then over here, I'm going to go ahead and distribute this -2. -2 times a, -2 times -2. So I get -2a and plus 4. So just be careful if when you're going to do all of the work in one step. That is a -2. Okay. All right. And then here we get 3a. Oh, no, actually, we get 3 minus 2 is 4, 1a. And then -3 plus 4 is 1. So that is our final answer here. Okay. Again, factor, get your LCD between all 3 terms. LCD is a minus 2, a minus 1. Multiply all 3 terms by a minus 2, a minus 1, and clear your fractions. And then you can go ahead and multiply and combine like terms. Okay? All right, let's take a look at this next example because it's written in a funny way, but it's still the same type of problem. Okay, so actually we're on example 4. All right, so suppose you get something that looks like this. It looks kind of strange. X to the -1 plus y to the -1 over x to the -2 minus y to the -2. Okay, so all of these negative exponents. So what this is actually a complex fraction, because remember when you have negative exponents, you take the reciprocal. So this is just another way to write 1 over x. This is another way to write 1 over y. This is another way to write 1 over x squared. And this is another way to write 1 over y squared. So let's just go ahead and rewrite them like that. So that's 1 over x and plus 1 over y. And down below here, that's 1 over x squared minus 1 over y squared. Okay, so then we go ahead and do the same procedure that we were doing up above. You can decide between the 2 methods. If you want to use the division method, that's fine. If you want to use the clearing fractions method, that's fine too. Okay, so I'm going to go ahead and finish this off using the clearing fractions method. So I have to take a look at all of my terms. I have 4 of them, and I have to find the LCD. So I see x, the family x is going to be there, and I see the family y is going to be there, and I do have exponents here, so it's going to be x squared and y squared. Okay, so this is going to be my LCD, and that is what I am going to have to multiply everything by. So I'm going to multiply over here by x squared y squared, here by x squared y squared, over here, and over here. Okay, and when we do that, things should cancel. 1x will cancel out with only 1. 1y will cancel out with only 1. X squared cancels out with all of it. Y squared cancels out with all of it here. Okay, so let's see what we have left. Up here, I'm left with x y squared times 1. Over here, I'm left with x squared y times 1. Down below, I'm left here with y squared. And over here, I'm left with minus x squared. Okay, and oftentimes we're done once we get to this answer here, but I notice that these are difference of squares. So I'm going to go ahead and factor to see if I can cancel. So I'm checking to see if I can simplify my answer. Maybe I can, and maybe I cannot. So up above, that's common factoring. They both have x and they both have y, and that will be y plus x. Down below, that's going to be y plus x, y minus x, and fantastic. They cancel out. So the answer does simplify. So very good. And it simplifies to this. Okay, so always check to see if your answers simplify. Okay, but the point of this particular problem was to show you how to deal with a complex fraction when it's written in this strange way with the negative exponents. Okay, so again, that just means the reciprocal. So if you see that, it's 1 over x. If you see that, it's 1 over x squared. Okay. Okay. Other than that, that is pretty much it. So that is all for 6.4. If you have any questions, let me know, and just text me or email me.